This is mathheals.com, where you can find more links to math YouTube videos and computer science. Let's take a look at exponential and log integrals. Now we have our exponential rule that we'll look at first. It says the integral of e to the x dx is equal to e to the x plus c. Well, that's not very useful because most times you don't have a single x. If you have a u there instead, where u represents anything, and put that there, du, then this is just equal to u to the e to the u plus c. Now this seems like, well, it's the exact same thing, except for this represents a single variable, and this can be anything. Now I'm not going to write the full formula down for it, because this is one we'll mainly use. But let's take a look at our first problem. Okay, the integral of 5e to the 5x dx. Now recall when we used the u substitution before. We had some guidelines. Our first one is if you have something in parentheses to a power, you let u equal to what's inside the parentheses. If you have a radical of some form, you let u equal to what's inside the radical. We're adding a third one on here. If you have e to a power, well, try to let u equal to the power. There's a fourth one, I'll go ahead and write it on here. But if you have a fraction and you have something up on top, let u equal to the bottom part. Let u equal to the denominator. Okay, well, we have e to a power, so we're going to let u equal to the power, 5x. Now remember on this, we take the derivative of u. Derivative of 5x is 5, and then we add on the dx. Well, we have our 5x there. That's going to be replaced by that. The 5 dx all gets replaced by du. So this becomes the integral of e to the u du. Now remember, it has to match exactly. Everything has to be accounted for. Well, the integral of e to the u is e to the u plus c. And u we said was 5x. So we'll have e to the 5x plus c. And that's our answer. And let me put a box around this. Let's look at our second problem. We've got the integral of e to the 7x plus 1 dx. And if you're doing the u substitution, if you got e to a power, always try to let u equal to the power. Doesn't mean it'll always work, but that's where you start. So we'll try to let u equal to 7x plus 1. du will give us 7, and then dx. Well, the dx is there, that's fine, but we're missing a 7. Well, that's easy. We'll put a 7 inside. Now remember, you can freely put a number inside of your integral if you offset it with a reciprocal out in front. So we'll put a 1/7 out in front. Because 1/7 times 7 gives you 1, so we haven't changed it at all. Well, now the 7x minus 1 there matches that, so that's going to be replaced by u. The 7 dx dx. Everything has to match exactly, which it does. So then this becomes the integral of e to the u du. Well, the integral of e to the u is e to the u plus c. Now u we said was 7x plus 1. So we'll plug that back in. And that's our answer. Let's take a look at our next one. We got the integral of x, e to the 3x squared plus 1 dx. Well, if you have e to a power, always try to set your u equal to the power. Doesn't work, then you can try other combinations. Well, the derivative of 3x squared plus 1 gives us 6x dx. So we got the x, got the dx, we're missing a 6. Well, that's easy enough. We'll put it inside. Remember, with numbers, you can freely put it inside. You can't do the same with variables. Like if I was missing the x, I can't put an x here and a 1 over x out in front. Well, we put the 6 here, so we put the reciprocal of it out in front, so we put 1/6 there. Now everything matches. 3x squared plus 1, 3x squared plus 1. The 6x, 6x, dx, dx. Okay, everything's accounted for. So we've got 1/6, the integral of e to the u du. Well, the integral of e to the u is e to the u, and then my plus c. And u we said was 3x squared plus 1. So this becomes 1/6 e to the 3x squared plus 1 plus c. And that's our answer. Let's look at another one. The integral of 8 x squared e to the 4x to the third dx. Again, we got u to a power, or q to a power, e to a power. So we're going to set u equal to the power. U is equal to 4x to the third. Du, the derivative of 4x to the third, is 12x squared dx. Well, we got the x squared, we got the dx. Don't have a 12, we have an 8. So we got a number that really doesn't belong. So we'll throw the 8 out in front. We don't even want to worry about it. We need a 12 inside, so I'll put a 12 inside. And we'll offset it with a 1/12 out in front, the reciprocal of it. Okay, our 4x to the third matches our 4x to the third. The 12x squared, 12x squared, the dx. Everything matches. And this gives us 8/12. And this becomes e to the u du. We replace 12x squared dx with du. Well, this reduces. They're both divisible by 4. That gives me 2/3. The integral of e to the u is e to the u plus c. And u we said was 4x to the third, so I'll plug that back in for our u. And our answer is 2/3 e to the 4x squared plus c. One more of those type. Okay, so we got the integral of x plus 2 e to the x squared plus 4x minus 1 dx. Okay, we got e to a power, so I'll set u equal to the power. U is equal to x squared plus 4x minus 1 du. The derivative of that will be 2x plus 4 dx. Doesn't match what we have here. We have an x plus 2, but I notice I can factor a 2 out. And that'll give me an x plus 2. Okay, so it looks like that's okay. X plus 2 is there, the dx is there, of course. The 2 is missing. So we'll put a 1/2 out in front, and we'll put a 2 inside. So now this is accounted for. The 2x plus 2, 2x plus 2, and the dx are all accounted for. So we replace the x squared plus 4x minus 1 with u. The 2 times x plus 2 times dx gets replaced by du. Well, the integral of e to the u is e to the u plus c. And u, we said, was x squared plus 4x minus 1. So we plug that back in for the u. And that's our answer. Let me save this. Exponential log integrals. Page 01.pdf. There we go. Okay. We have another rule that says if you have 1 over x dx, that's going to be equal to the natural log of the absolute value of x plus c. And one that goes along with it, instead of a single variable, which we'll almost never have, we have u down there. And then du here. This will be a natural log of the absolute value of u plus c. Again, they look like the same formula. Difference is here u can represent anything. And it's a u substitution, basically. So let's look at our next problem. Got the integral of 1 over x plus 4 dx. Now remember our different rules. If you have parentheses to a power, u is equal to what's inside the parentheses. If you have a radical, u is equal to what's underneath the radical. If you have e to a power, u is equal to the power. And if you have a fraction, you can try to set the bottom part equal to u, which is what we'll do here. So we'll set u is equal to x plus 4 du. The derivative of x plus 4 is 1, and then we have to add on our dx. You always add on your dx. Well, 1's trivial, so we got this. So the x plus 4 is going to be replaced by u. The dx will be replaced by du. So this is going to become the integral of 1 over u du, which from our formula is equal to natural log of the absolute value of u plus c. And u, we said, was x plus 4. So we'll have the natural log of the absolute value of x plus 4 plus c. And that's our answer. Let's look at another one of those. We've got the integral of 9 over 9x minus 1 dx. Now, I deliberately wrote the instructions down differently. Let me find out what they really say. Well, I'll get there eventually. Give me some music. There we go. I just wrote down find the indefinite integral. Here they say use the log rule to find the indefinite integral. Up above they say use the exponential rule to find the indefinite integral. Really, when you approach a problem, you should think along those 4 guidelines I've given you. What should your u be? You shouldn't be the problem shouldn't be guiding you that much. Remember, parentheses to a power, don't have that. Radical, we don't have that. E to a power, we don't have that. So the only thing we've seen then is to try to let u equal to the denominator. Let's try that. u is equal to 9x minus 1. So the derivative of 9x minus 1 is 9, and then we always have to throw on our dx. Well, the 9x minus 1 here is going to be replaced by that. The 9 dx. Everything's accounted for. So the 9 dx is going to be replaced by du, and this will be replaced by u. So this becomes the integral of 1 over u du. The integral of 1 over u is natural log of the absolute value of u plus c. And u was 9x minus 1. So our answer is the integral of, the natural log of the absolute value of 9x minus 1 plus c. Okay, let's look at this one. Got the integral of 3 over 7x plus 2 dx. Start going through my guidelines. Parentheses to a power, no. Radical, no. E to a power, no. Fraction. Well, let u equal to the denominator. So u is equal to 7x plus 2. Then derivative of that, derivative of 7x plus 2 is 7, and then add on a dx. Well, we don't have 7, we have a 3, a number that shouldn't be there. So let's go ahead and put the 3 out in front. We don't even want to worry about it. What the number we really want to be there is the 7. So let's put the 7 there. And remember, when you put a number inside, you have to offset it with the reciprocal out in front. So we put a 1/7 out in front. Because 1/7 times 7 gives you 1. And numbers you can freely take in and out of an integral. That's why we can take 3 out. Now the 7x plus 2, 7x plus 2, 7 dx dx. So everything matches. We're going to replace the 7x plus 2 with u. So we got the integral of 1 over u, and 7 dx gets replaced by du. Well, our formula says that's going to be a natural log of the absolute value of u plus c. So we got 3/7 natural log of the absolute value, and u was 7x plus 2. So we now plug that in. And then plus c. And that's our answer. Let me grab a drink here. So we got x to the third and x to the fourth minus 2 dx. Okay. Parentheses to a power, no. Radical, no. E to a power, no. So our fourth u substitution try is let u equal to the denominator. So let u equal to x to the fourth minus 2. The derivative of x to the fourth minus 2 is 4x to the third dx. Well, we have x to the third, we have dx, we don't have the 4. So we'll put the 1/4 out in front, and we'll put a 4 inside. Again, you can put the 4 inside, you just got to offset with the reciprocal out in front. So now, the x to the fourth minus 2 is going to be replaced. The 4x to the third, the dx, the dx. 4x to the third dx gets replaced by du. So this becomes 1/4 integral of 1 over u du, which from our formula becomes a natural log, 1/4 natural log of the absolute value of u plus c. And u we said was x to the fourth minus 2. So plug that back in for u. And our answer is 1/4 natural log of the absolute value of x to the fourth minus 2 plus c. Let's take a look at our next one here. Got the integral of x minus 2 over x squared minus 4x plus 5 dx. We're going to let u equal to the denominator. So I got x squared minus 4x plus 5. Then du would equal 2x minus 4 dx. Which doesn't look like the top part, but the 2x minus 4, I can factor 2 out. And that's 2 times x minus 2 dx. Which now looks closer. The x minus 2 is there. I just need a 2 in front of it. So again, I'm going to offset it with a 1/2 out in front. And we'll have 2 times x minus 2 over x squared minus 4x plus 5 dx. Well, the x squared minus 4x plus 5 gets replaced with that. The 2x minus 2, 2x minus 2, the dx. So 2x minus 2 dx gets replaced by du. So this becomes 1/2 the integral of 1 over u du. And the integral of 1 over u du becomes 1/2 natural log of the absolute value of u plus c. And u was, what was u? X squared minus 4x plus 5 and plus c. Let's look at this one. At the integral of 2 over x times natural log of x to the 5th power dx. Now, if we start going down through our list, first one is if you got parentheses to a power, let u equal to what's inside of parentheses. Well, we have parentheses to a power, don't we? So let's try that first. So we'll let u equal to natural log of x. The derivative of that would be 1 over x. Then we have to add on our dx. And that actually seems to work out pretty good because this is in the denominator, which means this is like 1 over x dx. Now the 2 shouldn't be there, so I've got to move the 2 out in front. And then we'll have 1 over x natural log of x to the 5th power dx. So the natural log of x, this right here is going to be replaced with u. The dx, the 1 over x here is accounted for by this 1 over x. So what we're going to have is 1 over u to the 5th du. Well, we can rewrite this as u to the negative 5 du. And remember our rule. You add 1 to your power. So negative 5 plus 1 gives us negative 4. And you divide by your new power. Plus c. Which gives us 2u to the negative 4 over negative 4 plus c. 2 and 4 reduce, so both divisible by 2. So that gives us u to the negative 4 over negative 2 plus c. Now, we don't want any negative exponents, so I'm going to take the u to the negative 4 and move it down below. So this becomes 1 over negative 2u to the 4th power. Remember, when you move anything opposite of where it's at in a fraction, the sign of the exponent changes. So the u to the negative 4 becomes u to the positive 4. But u, we said, was natural log of x. So we want to plug that back in now. So we've got 1 over negative 2 natural log of x to the 4th power plus c. And that's our answer. Save that. let's look at our next problem. We got 5e to the x over 2 minus e to the x dx. Okay, let's think about our u substitution. Parentheses to a power. Don't have that. A radical. Don't have that. E to a power. We have that. But if I try to set u equal to the power, u is equal to x, I'd get du is equal to dx. And what we'd find is since these match exactly, this would just become 5e to the u over 2 minus e to the u du. We just change variables. You actually never do a u substitution where you just say u is equal to single x, because it doesn't make any sense. So that one fails. Well, then our last one. If you got a fraction, let u equal to the denominator and see what happens. So we got u is equal to 2 minus e to the x. Derivative of that, 2 drops away. Derivative of negative e to the x is negative e to the x. And then we add on our dx. Okay, well we have an e to the x here. We have a dx. The 5 shouldn't be there, so I'll throw the 5 out in front. We need a negative up there. That's okay, we'll put a negative there. That's like putting a negative 1 in there, right? Now, reciprocal of negative 1 is 1 over negative 1, which is just negative 1. So I have to put a negative 1 out in front. Negative times a negative becomes positive, so I haven't changed it at all. I just need negative in there for my du. 2 minus e to the x dx. So the 2 minus e to the x is going to be replaced by u. The negative e to the x, negative e to the x, and dx are going to be replaced by du. Okay. 5 times negative 1 is negative 5, and this becomes 1 over u du. Well, the integral of 1 over u du is natural log of the absolute value of u plus c. So our answer, we're going to plug our u back in. Our answer is negative 5 natural log of u, which was 2 minus e to the x, plus c. Okay, let's look at this one. Now, every once in a while, I have a student bring me a problem. They'll bring this one right here, and there won't be any work there. And they'll say, I can't figure out what u should be. And my response to them is, well, you haven't even tried. Until you let u equal to everything, you really haven't even tried. Now, we could go through our standard list. If you got parentheses to a power, let u equal to what's inside the parentheses. Well, we don't have parentheses to a power. If you have a radical, don't have a radical. If we have e to a power, don't have e to a power. If we have a fraction, well, we do have a fraction, don't we? Remember we set u equal to the denominator? Well, we just said that goes nowhere with this. Now I could set u equal to the top part. I could set u equal to 7x squared. No matter what, it doesn't seem to go anywhere. If you can't seem to get anywhere with a u substitution, look for algebraic manipulation. See how there's a single term down here? Well, what I can do is I can split this up into separate fractions. I can put 7x squared over x minus x over x plus 3 over x dx. Well, then this becomes 7x minus 1 plus 3 over x dx. Now, you can split these into separate integrals if you need to. Some people do, some don't. And I'll put this negative out in front. And this would be 1 dx plus the integral of 3 over x dx. Okay, with the log rule, we know how to handle 1 over x. So I just need to take this 3 out in front. And I can take that 7 out in front if I wanted to, but I'm going to go ahead and do these. If you got x to the first power, you add 1 to your power, divide by a new power. minus, this is 1. If you got a number in here, you just put an x next to it. It's 1x. Plus 3, and then the integral of 1 over x dx. So that gives us 7/2 x squared minus x plus 3, and the integral of 1 over x dx, log rule, is the natural log of the absolute value of x plus c. And that's our answer. So again, split them into separate fractions and separate integrals, and then handle them that way. So that's one algebraic technique. This next one is kind of a variation of that. And we've got the integral of e to the 7x plus 2e to the 5x minus e to the x all over e to the 5x dx. Well, go through my list. Parentheses to a power, you let u equal to what's inside of parentheses. Well, we don't have parentheses to a power. If you have like a radical, we don't have radical. I'm watching James Bond. I should be focusing on the calculus here. It's a James Bond marathon. It's Thanksgiving. Okay, focus. If you have e to a power, you let u equal to the power. Well, I could go through and let u equal to 7x, let u equal to 5x, let u equal to x. These wouldn't go anywhere. So that fails. So then, the log rule. We let u equal to the denominator. Well, if I let u equal to that, it still wouldn't go anywhere. Well, this is another one where we split them into separate fractions. So we got e to the 7x over e to the 5x plus 2e to the 5x over e to the 5x minus e to the x over e to the 5x dx. Okay, now recall, if I had a fraction and I had like x to the 5th over x squared, we would subtract the exponents. Doesn't matter that these are e's, that's still the same idea. Well, 7x minus 5x is 2x. Now here, these are both e to the 5x, so those cancel. We're left with 2 minus x minus 5x gives us negative 4x dx. I'll grab a drink here. Okay, let's put these into separate integrals. So we've got the integral of e to the 2x dx plus the integral of 2 dx minus the integral of e to the negative 4x dx. Okay, now we have to do the u substitution here. And so in this particular one, here u is equal to 2x. Because we've got e to a power. So then du will be 2 dx. So now this 2x here gets replaced by u. The 2 dx dx, but I need a 2 in there. That's easy. Put a 1/2 out in front, and then we'll put a 2 inside. So then 2 dx, 2 dx, and 2x, 2x. That's going to be handled now. Well, we know how to handle this one. I might as well go ahead and just do it. If you got an integral of a number, it's just you put an x in there with it. Now this one, I could use u since we're already done with that one, but let me put a different variable so it doesn't get too confusing. W. Doesn't matter what variable you actually pick. U substitution, if you got e to a power, let the power equal to your variable. Then dw, the derivative of that gives us negative 4, and then we have to add on a dx. Okay, the minus is carrying down. We need a negative 4 inside. That's easy, we'll put it inside. Now we have to offset it with the reciprocal of it out in front. Well, this would be negative 1/4. Because negative 1/4 times negative 4, negative times negative is positive, and 1/4 times 4 is 1. Okay. Negative 4x is going to be replaced by u. The negative 4, the dx, both those get replaced by dw. Did I say u here? That should be replaced with w. And I'm about us. Oops, I need to scroll down. There we go. Okay, so this becomes 1/2 the integral of e to the u du plus 2x. Negative negative becomes a positive 1/4. The integral of e to the w dw. Which integral of e to the u is e to the u. So we got 1/2 e to the u plus 2x plus the integral of e to the w is e to the w. And then we have to add on our plus c. Well, u we said was 2x, so this becomes 1/2 e to the 2x plus 2x plus 1/4 e, and w we said was negative 4x, and plus c. And that's our answer. So again, had to split them into separate fractions. Do a little bit of algebra to get all of them simplified as e to a power or just a single number. Had to do our u substitution and w substitution. So we had to do our substitution twice here. And then came down with this. Let me save that. And let's look at our next problem. We've got the integral of 18x minus e to the x, and then the square root of 9x squared minus e to the x dx. Okay, start going through our different things. Try parentheses to a power, that doesn't fit. Radical, yeah, we do have radical, don't we? So let u equal to what's underneath the radical. So 9x squared minus e to the x. Then derivative of that gives us 18x minus, and the derivative of e to the x is e to the x, and then dx. Which actually everything's perfect now. That matches. And then the 18x minus e to the x, 18x minus e to the x, dx matches. So then this becomes the integral of the square root of u du, which we want as u to a power. So square root of u becomes u to the 1/2 du. Now add 1 to our power, divide by our new power. Then plus c, which gives us u to the 3/2 over 3/2 plus c. Remember, if you got a single fraction down below, you flip it and multiply times your top part. So it becomes 2/3 u to the 3/2 plus c. And I don't remember what u was. Okay, u is that. So then we have to plug in our u equals 9x squared minus ex. So this becomes 9x squared minus e to the x to the 3/2 power plus c. And that's our answer. Let's look at this one. This one's kind of a tricky one if you've never seen it before. It's got a little bit of algebra manipulation. Okay, parentheses to a power. We don't have parentheses to a power. Radical. We don't have a radical. e to a power. Yeah, I do have that. But if we set u equal to negative x, it really doesn't go anywhere. Then the log rule. Set u equal to the denominator. That goes even less. With this one, notice the e to the negative x. We could rewrite that as 1 over e to the positive x. Remember, you can take anything opposite of where it's at in a fraction. And the sign of the exponent changes. So we put that over 1 and then take it downstairs and get this. Well, we don't want a fraction inside of fractions. We multiply everything by e to the x. So we multiply the 4 by e to the x. We'll multiply the 1 by e to the x. And we'll multiply the 1 over e to the x by e to the x. Which would give us the integral of 4 e to the x over e to the x plus 1 dx. Okay, well, how does that help us? Well, now let's we'll use a log rule. I'm going to let u equal to the bottom part. So I got e to the x plus 1. The derivative of e to the x plus 1 is e to the x, 1 drops away, dx. Which is what we have on top, except for the 4, that's extra. So we're going to put the 4 out in front. E to the x over e to the x plus 1 dx. So the e to the x plus 1 is going to be replaced by u. The e to the x dx, e to the x dx is replaced by du. So this becomes the integral of 1 over u du, which becomes 4 times the natural log of the absolute value of u plus c. And u we said was e to the x plus 1. And this is probably our answer. I say probably. This would be good enough for my class. But in some books you may see they actually do this. They drop the absolute value. And you're sitting there, whoa, why'd they just drop it all of a sudden? You know, every other problem had absolute value bars in there, and all of a sudden they left us off. Must be a typo. Well, think about e to the x. No matter what I put in for x, it's positive. If I put 2 in, think of e as 2.7, but think of it as 2. If we had 2 to the, let's say 3, so if you put 3 in for x, you got 2 to the third, that's 8, that's positive. If you put negative 3 in there, you'd have 2 to the negative 3, which is 1 over 2 to the third, which is 1/8, which is positive. If you put 0 in here, e to the 0 is 1, so it's positive. So this is always positive, the 1's always positive. Positive plus positive is positive. So these absolute value bars aren't necessary. So they'll just drop it in some cases. So something to keep an eye out for. I might have room here, but let me start a new page. Okay. Number 17. Got the integral of x squared minus 7x plus 2 over x minus 2 dx. Okay, I start going through my different things to try with u substitution. Parentheses to a power, we let u equal to what's inside of parentheses, don't have that. If we have radical, let u equal to what's inside the radical, don't have that. If we have e to a power, well, I don't have e to a power. But if I did, I'd let u equal to the power. Fraction, set u equal to the denominator. So if I set u equal to x minus 2, it goes nowhere. So it fails. I won't go through the steps, but I know it will. Well, this algebraic technique, you notice that the degree of the top is 2, degree of the bottom is 1. Degree of the top is greater. If it's greater than or equal to the bottom, you can try to use long division. So I'm going to divide the top part by the bottom. Remember the long division, we look at the first term of each, decide what to put up on top. You ask yourself what times x gives you x squared, and that'd be x. Now whatever you put up on top, you multiply by what's out in front. So I'm going to take x times x minus 2, which is x squared minus 2x. Now we're going to subtract that, which means we'll flip the signs. So this becomes negative, and this becomes positive. X squared minus x squared drops away. Negative 7x plus 2x is negative 5x. And then I'll bring down to plus 2. Now again, we look at the first term of each, decide what to put up on top. You ask yourself what times x gives you negative 5x. And that's negative 5. Whatever you put up on top, you multiply by what's out in front. So we're going to take negative 5 times x minus 2, which gives us negative 5x plus 10. And again, we're going to subtract that, which means flip the signs. So this becomes positive, this becomes negative. Negative 5x plus 5x drops away. 2 minus 10 gives us negative 8. Which means that this problem we can rewrite as x minus 5 plus, take our remainder and put it over what we're dividing by. So again, what's on top here goes here, take your remainder, divide by, or put it over what you're dividing by. Well, now we can split these into separate integrals. So I got the integral of x dx minus the integral of 5 dx. I put the negative out in front of the integral. And I know I don't want that negative 8 inside there, so I'm going to put the negative 8 out in front and the integral of 1 over x minus 2 dx. Well, these two are pretty obvious, but this one's the u substitution. You know, if I go through all my steps, my last one, let u equal to the denominator. So u is equal to x minus 2. du would, the derivative of x minus 2 is 1. So du would just be equal to dx. So x minus 2 there gets replaced by u. dx gets replaced by du. Okay. This is x to the first power. Add 1 to your power. Divide by your new power. So that gives us 1/2 x squared minus number, you just put an x on it, minus 8. And then this becomes 1 over u du, which gives us 1/2 x squared minus 5x minus 8. And the integral of 1 over u du is natural log of the absolute value of u plus c. So we've got 1/2 x squared minus 5x minus 8. Natural log of the absolute value, and u we said was x minus 2 plus c. And that's our answer. Let's look at another one of those. Okay. Get the integral of x squared minus x minus 2 over the x squared minus 3x plus 1 dx. Now if I went through my different techniques, parentheses to a power fails, radical fails, e to a power fails. We do have a fraction. If I set u equal to the denominator, that would fail. Then I noticed that the degree of the top is 2, the degree of the bottom is 2. They're the same, aren't they? Well, I can use long division on this. So I got x squared minus 3x plus 1, and divide that into x squared minus x minus 2. Again, we look at the first term of each, decide what to put up on top. You ask yourself what times x squared gives you x squared, and that'd be 1. Well, whatever you put up on top, you multiply by what's out in front. 1 times x squared is x squared. 1 times negative 3x is negative 3x. And 1 times 1 is 1. Now we're subtracting that line, which means we flip the signs. So this becomes negative, and this becomes positive, and this becomes negative. X squared minus x squared drops away. Negative x plus 3x gives us 2x. Negative 2 minus 1 is negative 3. So this problem becomes 1 plus 2x minus 3 over x squared minus 3x plus 1 dx. Now I can split these in separate integrals. So we got the integral of 1 dx plus the integral of 2x minus 3 over x squared minus 3x plus 1 dx. Well, this one right here, if I go through my different techniques, parentheses to a power, no, radical, no, e to a power, no, fraction, set u equal to the denominator. U is equal to x squared minus 3x plus 1. The derivative of that would give us 2x minus 3, and then we put on a dx. And that matches. This becomes u. The 2x minus 3 dx, 2x minus 3 dx gets replaced by du. Now the integral of 1 is just 1x. And then this becomes the integral of 1 over u du, which gives us x plus natural log of the absolute value of u plus c. And u was x squared minus 3x plus 1. So plug that in for our u. Then we get x plus natural log of the absolute value of x squared minus 3x plus 1 plus c. Let's save that. Now, one other thing I ought to mention. Maybe I ought to mention it before I save that. I don't think there's any in the current textbook we're using that are like this. But, if you have something that looks like this, it's possible that one algebraic technique that you might want to use is to try factoring and see if something would cancel. Like this one here, the x plus 1s would cancel. And you got the integral of x minus 1 dx, which becomes 1/2 x squared minus x plus c. So it becomes a very simple problem by factoring and canceling. Okay, now I can save that. Like I say, our current textbook doesn't have that, but you never know what the new one might. And I might reuse some of these, so. There we go. Let me stop the recorders.